Alright, this video we're going to look at the gradient. Now the gradient is a measure of the slope of a line. Now we're going to start with this triangle over here. You can see over here that it's got this hypotenuse, okay, the line that's got the slope on it, and what I've got is a right angle triangle here. In order to calculate the gradient of a line, what you need to work out is the proportion of how far it rises, so the vertical distance that it rises, as well as, or over the top of, the distance that it runs. So, the gradient of a line, the formula for the gradient of a line is the rise divided by the run. So, let's do some calculations over here. So, if we say that the gradient is equal to the rise over the run, then we need to actually give this some numbers. Now, I've measured this, and at the moment our rise, the value for our rise is 2. And in the time that this line here rises 2, it has a run of 4. So it goes 4 units horizontally in the 2 units that it rises. Remember, we're calculating the gradient of this top line, the hypotenuse. So, in order to calculate the gradient of this line, what we would do is we'd put the rise, which is 2, and divide that by 4, and we'd end up with a gradient of 1 over 2, which is a gradient of a half. And so that gives us the slope of this line. Now we can apply these calculations to our Cartesian plane. So over here we've got 2 lines on our Cartesian plane. Let's get rid of our little drawing over here. Alright, so our 2 lines on our Cartesian plane. We've got this line here which is sloping in towards the right hand side, and you can see that it goes through the value -6, and so it intersects with the x-axis at -6, and it intersects with the y-axis at +6. And so if we consider just this part of the slope, okay, that makes a triangle with our coordinates, with our axes, then in the time that it runs 6, it rises 6. And so if we do our calculation for our gradient, we can use the value m to represent our gradient. Then it means that we have a run of 6 units, and at the same time that that intersection runs 6 units, it's going to rise 6 units. And so that means that the gradient of our line here is going to be 6 divided by 6, and that's equal to 1. And so this line here has a gradient equal to 1. Now, if we consider our other line here, you can see that our run, okay, if we look at where it intersects with the x-axis, it's at -3, and it runs to 0 before it intersects with the y-axis down here. And so you can see here that it's heading to the right, 1 unit, 2 units, 3 units, and so this side here would be 3. But in the time that it runs, it doesn't actually rise. You can see in the time that it heads, or in the space that it heads from -3 to 0, it actually drops. And so that's going to give us a negative value. And so if we look down, we've got -1, -2, -3, 4, 5, -6, -7. And so it intersects with our y-axis at -7. And so our our rise is actually -7. So for this second line here, we've got a run of 3, +3, and in the time that it runs those 3, it drops -7. So for our second line here, we would have m being equal to 3 divided by -7. And so for our second line here, the green line, we have a gradient of -3 over 7. Hopefully that will help you to be able to do some calculations with the slope of a line.